So after students create a prototype, highlight and fix is the next step in the design process. This is where the real magic happens when students redesign their designs. So you can see in the picture that these are 5 different bubble wands, and this was a first time trial. The reason why I love using the bubble wands in 3D design is because it takes so little amount of time to print them, so that students can really be able to create something and watch it fail and then recreate. So during highlight and fix, this is when I bring the examples of their first designs, and students have the opportunity to really reiterate their designs. We have a discussion around, okay, so do you think this bubble wand will work? And if they say yes or no, even if they say yes, how can you improve this? And it could be as simple as making the wand a little bit longer, but it gives them a chance to really see what they have created in the virtual world actually come to life in the physical world, and how that relates to 3D printing. And then finally, they each select their final design, and I check in with each student.
In our highlight and fix, we printed a few different students right away. One student that we printed first had her design completely flat on the build plate. Was the typical bubble wand like you saw in some of Carrie's images, that printed beautifully, came out, and students were all excited. And then we started the next design, and what you see on the screen, sitting on the MakerBot printer build plate, is what came out. And it was really interesting for students to start looking at and asking questions as it became this massive pool of filament instead of the wand that they thought was going to come out. So it was from there that the questions actually stemmed, from their experience instead of me driving the questions. And they said, what is going on with that, and why did it fail? And so what we did was bring the entire design up and look at it on our smartboard, and look at what you see over on underneath the H. That is the student's design, or what it was supposed to look like. But one of the things that we pointed out is, if you look at the tip, like where the pointy end is, you can see that the ridge on the bottom actually lifts the entire design up off the build plate, except for where that ridge touches. And so we talked about ways that design could be improved to be able to actually print decently, just by making some of the ridges a little bit bigger or smaller. This student actually also started with it standing straight up on its tip. And so we talked about, would that print, why or why not, and really talked through how much surface area the printer needs to be able to really fuse the print to the build plate and have a successful print. So it really gave us some great conversation pieces. And then students went back and were able to really dive in and fix some of their designs without troubleshooting each individual design as a class.
And speaking of that, one of the things that I've really struggled with is that initially a design in Maker's Empire looks flawless. I download the STL file and then put it on the printer, and we sit and watch it fail over and over again. And what I've learned is that I now use a slicing software to be able to look at these designs a little bit more in depth with students. And this is Slicer. It's used for Prusa, and it's a free download. But what it does that I need to be able to do with student designs is it allows me to get a 360 view, and also to be able to see, for example, like this design obviously is a printable design. Prior to this design, the snowman was slightly above the build area. So as soon as it got to the base of the snowman, the print would start to fail, and we couldn't see it until we literally put it in the slicer program and we were able to look and turn it. I now do this with all of my students prior to printing something so that they can look at the design with me and sort of figure out, okay, is this going to work? Where could it possibly fail, knowing how a 3D printer works? And this has saved me quite a bit of time in printing.